All right, we got lesson 6.1 here, just basic looking at different types of roots and radical expressions. We're familiar with using square roots, but now we're going to do third roots, fourth roots, fifth roots, sixth roots, nth roots. As we go through, I might call something an odd root. Something that is an odd root would be like a third root, a fifth root, a seventh root, so on and so forth. Or I might say an even root. That would be your square roots, fourth roots, sixth roots, eighth roots. So that's what I'm talking about anytime I say odd or even. Our first example, I've got what would be read as the third root of 8. Simply means this. What do you take times itself 3 times to get 8? So something to the third is 8. The third root of 8 is, saying to yourself, what to the third is 8? So what to the third is 8? Well, that would be 2. 2 times 2 times 2 is 8. As we're going through these, you might want to have that half sheet out that I gave you in class. It's got all the different powers on it. It's got first power written through 10th power. Then we got the numbers 1 through 15. You'll find that sheet can be kind of helpful to have in hand while you're doing these types of problems. Okay. All right, on this next set of problems, 2, 3, and 4, you'll see I have all odd roots. I have fifth root, seventh root, third root. When you odd root something, you get the same sign as what's on the inside. So on the first one here, I've got the fifth root of a negative. That means I'm going to get a negative. The second one is the seventh root of a positive, so this one's going to be positive. And the last one is third root of a negative, so that one's going to be negative. Anytime you odd root a number, you get the sign of that number that you're rooting. The other part of it, you could simply go ahead and look at your half sheet that I gave you with the powers. In order to do the fifth root of 1024, what you should do is look at the fifth power column. And you'll notice that 1024 is on there. It goes 1, 32, 243, and then there's 1024. 1024 is the fourth number down. That means that the fifth root of 1024 is 4. So the fifth root of negative 1024 is negative 4. That's how you use that chart. Just go to the column and then see how far down you are when you're rooting. Apply that to example 3. 16,384, and I want to seventh root it, so I'm going to go to the seventh power. And again, I see that's the fourth number down in the seventh power column. So the seventh root of 16,384 is 4. This one again is positive 4 because it was positive on the inside. Example 4 has a fraction. You could split it into 2 parts if you like. You could say the third root of negative 1 over the third root of 27. Third root of negative gives me a negative. The third root of 1 is just 1. 1 times 1 times 1 gives me 1. And what's the third root of 27? What to the third is 27? 3. You could go ahead and look on the third power column on your half sheet, and you will see 27 is the third number down. So that's what the third root of 27 is 3. I'm going to go ahead and show you how you can use your calculator to type in something like the fifth root of negative 1024, so you have that information. Let me bring up my calculator. And here's how I would type in the fifth root of negative 1024. First I would hit 5. Then I go to math. And you can see that number 4 has a third root. So if I wanted to do a third root, I could go ahead and just do number 4. But I wanted to do a fifth root. So I'm going to hit number 5 because it's got that X in front of it. And then I'm just going to type in negative. Make sure you hit negative and not the minus sign. having trouble getting to my negative symbol here, based on the screen. There it is, way down there. Okay, there's a negative symbol. And then we'll type in 1,000. And we'll just press enter, and you can see that we get that -4 that we found on example 2. One more, if I want to do the 7th root of 16,384, it is 7 for 7th root, math, number 5, and then 16,384, enter, and you can see there's the +4. So you can use your chart or you can use your calculator. On most of these problems where they're on the chart's pretty slick. And so that's odd rooting. Moving on, here we have even rooting. Even rooting we've done before. We've done square roots, and that's a little bit different. You can't square root just anything. When you square root a negative, we learned that we're going to use imaginaries. Well, we're not going to use imaginaries on the rest of them. What I mean by the rest of them is 4th root, 6th root, 8th root, 10th root, all the other even roots. So if you don't have a square root, but you have an even root, we're not going to put imaginaries. We're simply going to say, you know what? We used to say the square root of negative 81 had no solution. Now we say it's 9i. But we're going to go with that same type of thinking right here. Here, we got an even root of a negative. We're just going to say no solution. Just like when you square root something, if I said the square root of 81, moving on to example 6 here, you just say 9. You don't say both, positive and -9. You only do that when you're solving for some x like squared, or and this we'll be doing x to the 4th or x to the 6th. But if I solve for x squared, you're going to get both answers, plus or minus. When you're just evaluating, you just put the positive. So again, look at your sheet under the 4th power column, look for 81. And if you look on the 4th power column, number 81, it's the 3rd one down. So the answer is just going to be +3. I'd encourage you to pause right now and see if you can get the answer to number 7. See if you can use your half sheet to get number 7 and just check to see if you got it right. All right, I'm checking here. It's got an 8th root. So I'm looking for my 8th root, and I see that that number matches the number that is 9 down. So the 8th root of 43,046,721 is 9. Just put the positive. Okay, next page, moving on. If it was only this easy, it's not this easy. I'm asking, is the square root of x to the 6th equal to x to the 3rd? And sometimes when you want to prove something works or doesn't work, you plug in some numbers, you know. So let's just say x is 2. Let's say I want to show that the square root of 2 to the 6th equals 2 to the 3rd. Well, the square root of 2 to the 6th, I know a quicker way to do this, but just to, well, how you might do it, you might do 2 to the 6th, and you might say that's 64. And you'd say 2 to the 3rd is 8. And hopefully right here you'd be going, hey, that's true. It's true. But what if I said use -2 and not +2? What if I said x was -2, so I put it in parentheses, like this. When we plug in a negative, we got to use parentheses, otherwise we might have a problem. Well, in this case, I would have square root of 64 equals -8. And that is not true. So there's a problem here. Is this true? Yeah, sometimes. In this case, it's true when x is positive. Or it also would work if x is 0. So I should say when x is not negative. But what this shows is you have a problem when you even root. When you even root something, you're always going to get a positive. You can't get a negative. So we need to understand that when we even root something, in order to make sure we don't get a negative, we're going to end up using absolute value symbols. So whenever you even root, put absolute value symbols around your answer, and then we're going to simplify from there. Another thing you need to ask yourself is, can x be negative? In this one, x could be negative, because when I plug in a -2 right here, it turned into a positive, and I'm perfectly legal to square root a 64. If I would have said square root of x to the 5th, you should say x can't be negative, because if I put -2 in here for x, you get the square root of -32, and you'd be going, well, we just said on the previous page that you can't do that, or this one would be imaginary. So it's going to be important to make that connection. Can x be negative? If it can be negative, then we need to use absolute value symbols when we even root. All right, so here's what I got. I got an even root. There's no x, so I don't need to worry about that. So in here, I'm just going to go ahead and evaluate. -2 to the 4th is positive 16. The 4th root of 16 is positive 2. So you see what happened here? My -2 actually turned into a positive 2. That's that whole we're going to need to use absolute value thing. So you could also have said the 4th root of 16 is the absolute value of 2, because we're even rooting, and of course that is 2. Okay, example 9. Break this into two pieces here. We're going to square root 25, and we're going to square root x to the 8th. You can do that, or you can do it all at once. It's up to you. Let's go all at once. It's an even root. Can x be negative? Well, if I put x as negative something like -2, it's going to turn into a positive because it's going to the 8th. So x could be negative. So since x could be negative, and I'm even rooting, I'm going to put absolute values. And I'm just going to square root each of those. What's the square root of 25? Well, that's 5. What's the square root of x to the 8th? Well, that's a little different. When you square root something, you can take things out in pairs. Like if I asked you to do the square root of 5 squared, you should say that's 5, because you have a pair of 5s. If I say, what's the square root? By the way, when I can put a 2 here, that also means square root. So if you see a 2, that's the same thing as if there's nothing there. If I put the square root of 5 to the 4th, well, that means you have the square root of 2 pairs of 5 squares. That's what 5 to the 4th is. So you'd end up with 1 5 on the outside for the first one, and another 5 on the outside. Well, a quick way to do this, guys, is to simply say I'm going to do 4 divided by 2, and that's how many 5s go outside. So up here it's square root, I can pretend there's a 2 here. I'm going to do 8 divided by 2, because they come out in pairs. If I have 8 x's, that means I have 4 pairs. Now you can split absolute values up into pieces. You can do the absolute value of 5 and the absolute value of x to the 4th. Well, the absolute value of 5 is 5. Well, it turns out that the absolute value of x to the 4th is just x to the 4th. You really don't even need the absolute value symbols, because if you take something to the 4th, you can't get a negative anyways. So when I even root, I need to make sure my answer can't be negative. And because no matter what x is, when I take it to the 4th, it'll be positive, I don't need the absolute value symbols. I'm assuming this will be a little bit tricky until we do a little bit more practice. So let's continue on. Example 10, can x be negative? Yes, x can be negative because when you take something to the 12th, it ends up being positive. And you can 4th root a positive. So I'm going to turn this into the absolute value of, what's the 4th root of 625? You can either look at your sheet or say, well, 5 times 5 is 25. And 25 times 25 is 625. So what's the 4th root of 625? 5. because 5 to the 4th is 625. You see how that 4 divided by 4 is 1. So that's 5 to the 1st. How many x's do you end up with? 12 divided by 4 gives me 3 sets. So this one we can split up into the absolute value of 5 times the absolute value of x to the 3rd. Well, the absolute value of 5 is 5. The question is the absolute value of x to the 3rd always positive? Because you can't even root and get a negative. And the answer to that is no. I could have, at the very beginning, said x is negative 2. It would have turned to a positive on the inside. And we could have taken it out like we did, made x a 3rd. But now if I put negative 2 in over here, I end up with a negative unless I have that absolute value symbol, those absolute value symbols going there. So on this one, I actually leave the absolute value of x to the 3rd in my answer. That's for even roots. 11, piece of cake. It's an odd root. Don't need to even really think about it. I can odd root anything. And I just get the sign of whatever's on the inside. 3rd root of 64. Well, 64 is 4 cubed. 3rd root of 64 is 4. 3 divided by 3, 1. How many x's do I have? Well, 9 divided by 3 is 3. I don't care about absolute values at all on this one because I was odd rooting. And I can end up with a negative answer. Okay, last one. Even rooting. So I got to check it out. Got to be careful. I got 2 variables in there. Got to ask myself, could x be negative? Could y be negative? And yes, they can. Because when you take a negative to the 12th, you get a positive. When you take a negative to the 18th, you get a positive, and you can 6th root positives. So x and y could be either positive or negative. So I'm going to do absolute value. How many x's? 12 divided by 6 is 2. How many y's? 18 divided by 6 is 3. Now we're going to split this into parts. I don't need absolute value x squared because no matter what the number is, when I square it, I end up with a positive. So the x squared doesn't need to be in absolute values. You're being redundant. You're saying something that doesn't need to be said. Okay? We're already telling you that this is positive by the fact that it's x squared. Y cubed, on the other hand, could turn into a negative. If y were a negative right here, you'd end up with a negative over here. So the y cubed stays in. Okay, so kind of the culmination of what I'm saying here is if you have an even on the outside and you end up with an odd, if you end up with have an even root and you end up with an odd power in your final answer, that expression with the odd needs to be in absolute value symbols. Okay, that's the basics of our nth rooting. Thanks for watching. Have a great day.